Hi everyone, this is my final presentation for new musical interface design, and my final design challenge is called Tone.js. So I'm going to talk a little bit about the inspiration for making it, my process of making it, and then give a demo. So if we go back to the point in the semester when we were studying step sequencers and look at some of the ones I studied, then that'll give us an idea of how this came to be, because that's when I started to formulate my ideas for this project. So here are a couple of step sequencers I looked at while researching, and I really wanted to go for a wide variety of styles and ones that I thought were particularly useful or inspiring. And a common theme I noticed between ones I really liked were ones that had independence between different parameters and randomness and sources of uncertainty, and things that kind of embodied aspects of the physical world in the virtual. So a couple of those that particularly inspired this project were one called Meadowphysics by Monome, which is a Eurorack module that is enabled by their grid controllers. And I've never tried this, but I've seen people use it, and it's really interesting. The lights on the grid move kind of like bouncing balls or droplets, and when they hit a boundary, it either triggers an event in your modular system, or it can bounce, or there's all sorts of rules you can set up in parameters to kind of create your own interesting polyrhythms and unexpected sort of physics-based sequences. Another one is Tombola, I think it's pronounced, for the OP1, which I haven't tried or played with either, but I've also seen videos of. And it's just this like spinning hexagon thing where there's these particles in there that are notes that trigger notes, and you can change the how fast it spins. You can change the mass and the gravity and different parameters about the hexagon, and it creates these really interesting, unexpectedly expressive musical patterns. And that was a big inspiration for this. And another one was a VR game called Drops, which I guess you have these virtual 3D objects that emit droplets, and you can do different things with them and kind of create your own modular musical system in a 3D physics simulation. So these were all things that are too expensive for me to try myself. So I kind of wanted to make my own version because I was just watching people use them on YouTube and wondering why I couldn't do something like that. Another one, which isn't really an instrument, it was more of a music visualization animation. A guy called Doodlechaos animated these falling marbles that hit these drums that aligned with these drum loops. And it's not really software. You can't run this yourself. It's an animation that he made to sync up with music. But I really liked the idea of what if it was software. What if I could make a version of this that you could build your own and put whatever sample you wanted? And the Chrome Music Lab was a big inspiration because it showed what is possible with web audio and web MIDI, and it got me interested in trying to learn how to make applications like this that were freely available and easy to access through modern web browsers. So if you go back in time a little bit to the fall, I discovered this artist called I'm Robot and Proud, who I feel like I just resonated with on an aesthetic level, and was really inspired by their animations that they made for Instagram that were responsive visuals to their music. So I'm just going to play three of my favorites because I think they're just that good. from keeping up with his Instagram page, I learned that he made those animations with a programming environment for Java called processing that a lot of generative artists use. And he sent MIDI messages from a DAW called Renoise into processing, and that's what triggered the animations. So I wanted to try to do this myself, so I began to learn how to write code. I'd programmed a little bit in the past, but mostly like HTML, CSS, which aren't really programming languages, so this was like a big learning curve for me. So I'm going to show some early experiments in what I did that led to Tone Toss. So looking back now, I really appreciate the simplicity of this one. I was going for a simple Instagram animation loop, and that's what I did. And I just had these circles that fell at a certain, like a constant fixed rate, and they hit the virtual floor at the same time that a delay unit triggered a delay, which was a dotted eighth note. And it was all hard coded in there. This wasn't responsive, it wasn't dynamic. I couldn't really change it. It was just taking MIDI input and making these particles, and it just happened to line up with the delay rate. So it was a precursor to making interactive musical systems, but it was more just a music visualizer. So these animations were exciting to me because it was the first time where it was not just the animation responding to the music, but the music was also responding to what was happening in the animation. It was going both ways. There was MIDI going in from the keyboard to Ableton to processing, and then processing would detect collision events and then send MIDI back to Ableton. And this was really exciting to me, but it was still not accessible. It was rendered video that I composited in After Effects, and unless you set up the code and the virtual MIDI driver the same way I did, you couldn't really get the same result. So my next step was to move this to the web. And that's where P5.js comes in, which is the JavaScript version of processing. So it was a bit of a learning curve again to transition here, but once I did, I realized that there were so many cool libraries for JavaScript that I knew that this was what I should be developing for. So I used three main JavaScript libraries: Matter.js for the physics. It's simple 2D physics. And I know that you can integrate this with P5 because I'd seen it before on the Coding Trains YouTube channel. And I used Tone.js, which is a sound library for JavaScript that has all sorts of really cool musical features. You should check out some of these demos. And I also used P5GUI.js, which is a port of quick settings for P5 from what I understand. And it basically allows you to create a very quick and easy graphical user interface for your variables. And I wanted to do this as a quick and dirty way to just allow the users to change certain aspects of the simulation just to make it a little more exciting. So now I'm going to transition into the demo portion of the presentation and show you what this can do. All right, here we are at Tone Toss, which you can access by going to eelromance.github.io/tone-toss. And when you get there, the first thing you'll see is this wonderful blue background and a thing that's telling you to press Q, which opens settings. We'll get to those later. But first of all, it's the same thing as I've presented before, where you enter in notes with the keyboard. You change gravity with the arrow keys. You can throw them around with the mouse. You can press slash to change to applied gravity mode, which is zero gravity, and gravity is temporarily applied with the arrow keys. And you can press slash and then another arrow key again to switch back to the default, which is constant gravity, where the gravity is a constant direction and value. There's also a new voice mode, which is drums. We have 7 drum samples: kick, snare, rim, 2 hats, open and closed, and a high and a low tom. drum particles are circular and the melody particles are triangular. So let's go into the settings. We have voice mode toggle, which is the same thing as the keyboard, and gravity mode toggle, which can be accessed with C or / like I said before, or here in the settings menu. And we have 14 different waveforms. We have 4 basic ones, 2 pulses, and FM and AM versions of the initial 4. And it's important to note that this setting only applies to new particles. So if I have one that's a sine wave, then I change to pulse width modulation. I have a sine and a pulse width modulation particle in the same place. So it only applies to new particles. Same thing with lifespan, which says in frames how long the particle will last for. So at 60 frames per second, 600 will last for 10 seconds. And you can do the math. I want to change this to be seconds because it's more intuitive. A parameter that is in seconds is the reverb decay. That's in seconds. And wet is in percents. So 0 is completely dry, and 100 is completely wet. Particle size minimum and maximum changes the range of the particle size. It is randomized, but you can change this range to kind of get the results you want. If you have them all the way down, you get some really tiny particles. And if you have them all the way up, you might get some really huge ones. Big particle. Or a small one, because the range is pretty wide when you get up there. But it really just shifts the probability that way. Bounciness and friction, those change the physical properties of new particles. Similarly to waveform, they only apply to new particles. So if you have a friction of 0, you have a very slippery particle that doesn't really stop as easily as one that's at 1, which won't slide very far even when pushed. A bounciness of 0 means that a particle will only really collide once when it hits the wall, and a bounciness of 1 bounces about this much. So if you think that's bouncy, then try increasing it past 1 to 2, where you get some pretty strange effects. This one's pretty fun and chaotic. So you can see that they just actually bounce so fast that they left the environment. So I find with a bounciness of 2, change it to a sine wave so it doesn't blast your ears, and turn down the particle size so you get something more pointillistic like that. Also, the most important feature I forgot is background color. You can change it. So in case you want to green screen it in front of a beach or something, you can change the background color for both modes. Another thing I forgot to mention is transposition keys. So Z and X transpose up and down octaves, and 0 through 9, the number keys up here, transpose in semitones. So there are a whole bunch of other features that I wanted to include that I couldn't for time, and also because all of this is outside of my ability range. I had to learn how to do all of this as I went along, so I'm pretty amazed that I got this far, but there's much farther to go. For example, MIDI, that's one I talked about a lot, and I think it's really important, and I'm almost there. And I'm going to use the web MIDI library, so I can send MIDI output to a hardware synthesizer or a DAW, or get MIDI input from a MIDI controller or a DAW or another sequencer. So I'm going to use the web MIDI library for that. And I also wanted to control more things with the sound parameters. Oh, huge thing I forgot to mention, the filter. There's a filter on every sound particle, and its cutoff frequency is determined by the net velocity of that particle at any given frame. So that's something you probably already noticed by listening to the sounds. But I want that to be more controllable by the user too, like what kind of filter, how resonant is the filter, what is the range of the frequencies that are mapping, all sorts of things, and to get this sounding more kinetic and more responsive to what's happening in the physics. So those are all things I'm looking into in the future. And I'm also looking into developing more musical instruments or just sound toys that exist in web browsers that have some kind of musical and visual design logic that incorporates some of the indeterminate aspects of the real world, like physics, but in a way that only digital programs can do, because computers have a really good ability to calculate data, so they can sonify data, they can visualize data, and I think the marriage between the two is really exciting, and it has some really interesting expressive implications for music. And the most exciting part is harnessing the internet's ability to share those tools and to make them freely accessible and to allow people to make cool stuff with them. That's the ultimate goal of this. So thanks for listening to my presentation, and that's all for now.